Okay, today we're going to draw some Lewis dot diagrams. I had an idea on how I was going to do it, and it didn't quite work out the way I wanted to in the last little attempt at a video. So we're going to try this again and see how it goes. So we're going to start with CF4 as our first molecule that we're going to draw. CF4 has one carbon, and each carbon has 4 valence electrons. So that's 4 valence electrons times one carbon. And then we have fluorine, which has 7 valence electrons, and there are 4 of those. How do I know fluorine has 7 valence electrons? I'm going to look it up on the periodic table. So, let me zoom in a bit so we can all see what we're doing here. Okay. So we're going to add these up, and we have a total of 32 electrons that we're going to put in this molecule. So we start by figuring out which element goes in the middle. Molecules tend to be symmetrical. So we'll have carbon in the middle, because the rule is if there's an element that's single, you put it in the middle. And then we're going to have not 4 fluorines in a chain, but they tend to be more like a cluster usually. And so the 4 fluorines will go around the outside of the carbon. And now I need to draw my dots in. Remember, we have 32 valence electrons, so that's 32 dots. So here we go. We're going to fill around the fluorines first and then see what carbon needs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, counting to 32. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And that is the right number of valence electrons, and now we need to check if everybody's happy. Fluorine here has 8 valence electrons. This one has 8 valence electrons. This one has 8 valence electrons, and this one has 8 valence electrons. And carbon, because these are shared electrons belong to both atoms, carbon has those 8 valence electrons. So carbon is happy now, and everybody's got the 8 valence electrons they need. So this is a good, stable molecule here. The next one we're going to do is SiH4. So we have silicon, which has 4 valence electrons. We can look that up on the periodic table. And hydrogen has 1 valence electron each, but we have 4 of them. So that gives us a total of 8 valence electrons. Now, which atom is going to go in the middle? Well, it'll be the single atom. So silicon will go in the middle with 4 hydrogens around the outside. And normally from here you start drawing your dots on the outer atoms. But keep in mind, hydrogen only wants 2 valence electrons each. So it's not going to try to fill electrons all around it. It's only going to try to put electrons between it and the atom it's bonded to. So there I've got my 2 dots. I need 8, 2, 4, 6, 8. And it's always good to check. Does silicon have the octet that it wants? Definitely. And does hydrogen have what it wants? Remember, hydrogen is the atom that doesn't want an octet. It wants 2 valence electrons, so it can be similar to helium, which is the nearest noble gas. Remember, those electrons are in energy level 1, which can only hold 2 electrons, period. So, right, the next one we're going to try is CO2. And this one is a little bit different. So, CO2, we're going to do the same math. There's a carbon with 4 valence electrons each. So that's 4 times 1 is 4. And an oxygen with 6 valence electrons. Well, actually 2 oxygens. So we're going to have 16 valence electrons once we've drawn this in. So we're going to start by putting the single element in the middle. And oxygens on either side. And we want to draw 16 valence electrons. So we're going to draw them. First, we're going to make sure that these atoms are bonded together, and then we're going to fill our oxygens. So I've got 2, 4, 6, 8. And because this gets a little weird, I'm going to not draw them in, but use some papers here. 10, 12, 14, and 16. Whoops. They went flying. Go where you belong now. Okay. So this almost looks like a good arrangement. If we take a look at how many electrons each atom has, here we have oxygen with 8 valence electrons, oxygen with 8 valence electrons, but carbon only has access to 4 of those. So carbon is not happy in this situation. It needs 8 valence electrons. So sometimes people say, we'll just draw 2 more on the top and 2 more on the bottom. But then we wouldn't have 16. And we're not allowed to have more than 16 because these atoms only have these valence electrons. So you can't just create extra electrons. So what we're actually going to do is this. Carbon wants 8. What if we moved these two, instead of belonging just to oxygen, whoops, what if we put them here so they belong to oxygen and carbon? Like that. So now oxygen has 8 and carbon now has 6, so still not real happy, but getting there. So if we do the same thing on this side, we can move this pair of electrons in, and the carbon now has all of these electrons. That's 8. And the oxygen has all of these. That's 8. And everybody has 8 valence electrons. This, where the two atoms are sharing 4 electrons, 4 shared electrons, that's called a double bond. And I also wanted to show you that there's another way to draw these structures. The other way to draw these structures is to take every pair of shared electrons and draw it as a line. So we would draw C with 4 lines coming out because we have shared electrons here. These electrons belong only to the fluorines. And we draw our fluorines around, and then we could draw all the extra dots just like we normally would. So one line represents 2 electrons that are shared between 2 atoms. So now if we wanted to count, to make sure we had 32, we would say 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, and so on, and we should have 32 there. We can also count this way and make sure everybody's got what they need. Carbon has 8, that's 2, 4, 6, 8. Fluorine has 2, 4, 6, and 8. That fluorine's happy, that fluorine's happy, and that fluorine's happy because they all have 8. If we were going to draw this one the same way in the structural formula method, it would look like that. And because there are no electrons on those terminal atoms, those hydrogens, then we don't need to draw any dots. So this is all we need here. And here we can say silicon has 8 valence electrons, 2, 4, 6, 8, and each hydrogen has 2, which again, hydrogen wants 2, so it's happy, so that's good. And if we were drawing that for this molecule, then we would draw the C in the middle with a double bond on each side. Oops. And O's on the outside. And then the O's have each 2 pairs of valence electrons on them. So you could put those on the top and on the side, or you could put them on the bottom and on the side, or sometimes we'll do them like at an angle, like this. It doesn't matter. It works either way. So our goal here is to make sure that everybody has the number of electrons they want. 2, 4, 6, 8 for carbon, 2, 4, 6, 8 for oxygen, 8 for this oxygen, And lastly, we want to double check and make sure that we didn't exceed our number of valence electrons or go under. We gotta exactly match it. So 16 electrons, 2, 4, 6, 8, 10, 12, 14, 16. So that is good. So we're going to do one more, and if you would try to do this one on your own. Get my stuff back over here. This one we're going to do nitrogen. Nitrogen, if you recall, is one of those gens and enes, the diatomic elements, and it always bonds in pairs. So the atmosphere is 98% nitrogen, and all of the nitrogen is N2, like this. Nitrogen has 5 valence electrons times 2, so that's 10 total electrons. So I'm going to ask you to pause the video real quick and sketch out what you think the answer would be here and see if you can figure out how to make this work. And when you're ready, you can pause and check your work. Okay, so this is going to look like this. We've got nitrogen here and nitrogen here, and there's going to be at least one bond between them to hold them together. So I'm going to use these little guys and add them in. So I want up to 10. So I've got 2, so there's 4, 6, 8, and 10. So then we're going to look at each of the atoms and see if they're happy. Well, nitrogen right here has 2, 4, 6, and this nitrogen has 2, 4, 6, and they both want 8, so they're both not happy about this. So let's try that moving a pair of electrons from the outside in. So I'm going to move those two there, and with those two there, I'm going to tidy this guy up a tad too, make him fit better. So with these two here, this nitrogen atom has 2, 4, 6, again, and this one has 2, 4, 6, 8. So we're getting closer. This one has what it needs, but this one needs more. So this one is going to pull some electrons toward it, and those electrons are going to come from here, and they're going to come down here. So now, each nitrogen, oops, oh boy, I need to make these sticky or something, so they stick to my paper. Each nitrogen has what it needs, 2, 4, 6, 8, and this nitrogen over here, 2, 4, 6, 8. And if we wanted to draw that instead of as an electron dot diagram, we could draw it as a structural formula, and that triple bond would look like that. So if you want it tidy, it's going to look like that. So that's what nitrogen should look like. Okay, so you have a few practice problems to try on Schoology. So definitely make sure you have some paper out so that you can sketch these out on your own. Sometimes it's best to do this with a pencil and an eraser and, trial and error and do it a few times and see what works.